One question teachers constantly ask our PBL team is, what does problem-based learning really look like in a classroom? So we gathered a group of high school students who had never done PBL and put them in a classroom with an experienced practitioner. They were freshmen through seniors with all levels of math ability. We grabbed a camera, and this video is the result.
How many people here consider themselves to be good problem solvers? Wow, that's pretty good. So far, you've been taught using methods that have you solve closed-ended problems in general. There's usually an answer in the back of the textbook or a question in the back of the chapter with an answer, and you're always kind of striving to get the correct answer. In problem-based learning, it's a little different than that. Problem-based learning deals with real-world problems for which there may be multiple solutions. And how you approach the problem is just as important as the correct answer. And that's what we're trying to teach here, the problem-solving process. So what we're going to do today is we're going to present you with a real problem. Okay, the problem deals with laser safety. How many people have heard the news accounts of somebody pointing a laser pointer at an airplane or an aircraft as it's coming in for landing, and they end up getting arrested, and it's just not a good situation? Nobody? Yes? Happens all the time. It's on the news all the time. Anyways, so this one problem happened 2 or 3 years back, and turns out that this person was on the roof of a building down in New York, and was shining a laser pointer on an aircraft coming in. And the pilot of the plane, as it's coming in on approach, claimed that he was blinded by the laser pointer. So this problem was actually brought to my attention because I teach laser technology. They asked, the lawyers said, can this actually happen? Can you blind a pilot with a laser? And so I had students figure it out, and that's what you guys are going to do today. Now, how many people know anything about lasers and laser pointers? Okay, what do you know about how they work and what the issues are with them? What do you know about laser pointers?
It's a concentrated beam of light.
Right. Okay. And what are some of the characteristics of lasers? You can cook things, you can burn things with them. Okay, it's very powerful. The laser is actually brighter than the sun. Even the laser pointer, a small one, is actually brighter than the sun. Yep, another answer back here?
I think it does bend in light or a different substance. It's like actually using like a flashlight pointing it at water.
Yeah.
It bends.
Mm-hmm. Yeah, that's called refraction.
Yeah. Okay,
so whenever light strikes the surface, you get reflection, light reflecting off of the medium, and then it also travels through it and bends a little bit, and that's called refraction.
Well, you can use them for surgery.
You can use them for surgery, right? Which means if you shine it in somebody's eye, it's probably not a good thing, right?
They use them to cut parts of aircrafts.
Absolutely, yeah. So you guys get what lasers are and how dangerous they could potentially be. I mean, they have a lot of value, but they're also dangerous. So that's kind of the gist of what this problem is asking you to solve. What do you need to know? What do you need to figure out to determine whether a pilot can be blinded by laser beam? So I'm going to show you a short little video. And the video is going to introduce you to the whole field of lasers. Okay. Then we're going to look at another video that talks about the organization that is responsible for a lot of the laser safety activities that go on in the country. Then we're going to present you with a problem the same way it was presented to me by the lawyers. Okay? And then, so you're going to basically take my part, and you're going to solve this problem. We have tools built in to the PBL challenges that will help guide you through the problem-solving process. So when you're presented with the problem, listen closely about what information is given. Unlike a textbook where all the information is like right there and you just kind of have to find it, real-world problems are not like that. Some of the information is not given. Some of the information you just don't know, so sometimes you have to just make assumptions. But it's all about asking the right questions in order to arrive at a solution. So let's see the video. So the video that you just saw gives you a brief overview of the laser field in general, the different applications of lasers and what they're used for. One of the buttons that are available for each one of the sections of these PBL challenges is an additional resource button. And if you click on an additional resource button, you have links to the script that you just heard, basically the words that were said in the video. There is a link to the website for the Laser Institute of America, which is LIA. They're the ones who define laser safety standards in the country. There are some general laser safety rules that have been developed by other institutions, colleges, and universities, and just some other resources that can help guide you through the process of figuring out, what's safe, what does safe mean, and what precautions need to be taken when you're working with lasers. So the next section of the challenge is something we call the organizational overview. The organization is, or overview, is basically an overview of the organization that is tasked with solving this particular problem. So in this case, it's ILDA. So let's take a look at that video. Okay, again, like the previous section, there's an additional resource button here that has the script for what was just said, some additional resource information, link to ILDA's website, and other information. So the next video that you're going to see is the actual problem. It's a reenactment of the actual problem the way it was presented to me. You'll see that there isn't enough information to solve the problem. So you kind of scratch your heads and go, what do I do now? We're going to work with you about that. So here's how it went. Here's how it went down. All right. So, what's the problem?
If the slaves were powerful enough to impair the vision of the pilot.
Okay. Anybody else?
Yeah. When it hit the windshield, how could it have hit the pilot's sight as well?
Okay, so is there reflection off the windshield? Does the light get through the window? You have your hand right? It's the same thing too. What other information was given in that scenario? Look over here.
The pilot was at 1,500 feet.
Okay. Yeah.
It was a store-bought legal laser pilot.
Store-bought legal. Yeah.
Color of the laser was green.
Okay. Yeah.
He was coming into land.
Coming into land, it was on approach, right? Anything else? Anybody? Was it day or night?
Night.
Nighttime. Okay. What does that mean?
It'd be easier to see.
Say it again.
It'd be easier for it to pass through because it's dark
Well, yeah, I guess the laser would appear brighter to the pilot because it's dark out. Okay. So these are all the questions that you have to answer. Okay. Are there any assumptions? What was it? A clear night? Was it a cloudy night? Rainy? Foggy? Remember? You don't remember? Okay. Well, the good thing is that we have the script. The script is in there, so this is part of the problem-solving process. Now, what is the question that we're trying to answer here? Yes.
Could the pilot's sight have possibly been damaged by the laser?
Okay. Could the sight have been damaged by light? Good. Good. Anybody else? So the key word there is right. Is can the pilot's sight have been damaged by the laser? So, how do you answer that question? How do you figure that out? What do you need to know to figure that out? Yes?
How powerful a laser needs to be to damage vision?
Very good. Okay. What else?
How far a laser might be able to show? Like if you hold a flashlight really far away from like a wall, it's not going to show, so it might not be safe for a laser.
Good, good. Because if you take a laser pointer, you guys all know what laser pointers look like, right? You shine it on the wall, and the laser travels in a pretty straight line, right? But is it perfectly straight? Okay. Or does it start spreading out a little bit? Okay. So yes.
What angle did it hit the windshield at?
Good question. Okay. These are all the things that make real-world problems ugly. Okay. They actually make the real-world problems more interesting because there's not just here's X, Y, and Z, and just kind of plug it into an equation. Now, there's stuff going on. Okay, there's other things that you have to take into account. Plane's on to approach. How fast is it going? Okay, is it dark? Is it light? Is it raining? What happens when light travels through space? Does it scatter? Does it spread out? By how much? How much power is required to damage somebody's vision? As you said. So, in order to help you to organize your thinking and to ask all the right questions so that you don't leave any stone unturned, we've developed this, what we call the Problem Solvers Toolkit. And the Problem Solvers Toolkit has four main processes that make up what we call the problem-solving cycle. The first step is problem analysis. One of the most difficult things to do when you're solving problems like this, or even more complicated problems, is trying to frame the problem. And when we talk about framing the problem, we're talking about what is it that the problem is actually asking? What is a solution? What is the solution that we're trying to strive for? Okay, and it involves asking the right questions. Okay, once you've figured out, geez, here's all the things I need to figure out. Let me just show you this whiteboard that we've created. We actually created a tool for you that is, we call them the whiteboards. Okay, and the whiteboards are actually designed so you can actually project it up onto the whiteboard, so that when you start working on this, if you like, I can pull up the screen. You can actually write right on the whiteboard. But ask the question: clearly define the problem and list the criteria for a successful solution. And what is the problem? What do we know about the problem? List everything that you know. What do we need to learn? There's the hard part. Okay, and that's again about asking the right questions. Are there any special constraints or assumptions that apply, or assumptions that we must make? Okay. Things that you don't know, sometimes you just have to make assumptions and then test those assumptions. Okay? So listing out all of these parameters about the problem is what problem analysis is all about. Defining and framing the problem. Once you've figured out what you know and what you need to learn, then you need to put together a plan for going out and getting that information. Okay? So the next whiteboard is what we call the independent research whiteboard, sometimes called self-directed learning. Okay? And this is all about setting learning goals. What is it that we need to learn? Make a list of it. We're going to be working in teams. So you're going to have a team of 4 people. Okay? Everybody is tasked with finding out certain bits of information. Okay? How much time do we have? Okay? When does this due? And what is the strategy for acquiring the knowledge and skills needed to solve the problem? Where am I going to get this information? Am I going to go to the library, internet? Am I going to go talk to LIA, go to their website, Google search? There's a strategy that you deploy to find that information. Once you've done that, and you've gone out, you've researched, and I'm assuming we have laptops today, so you've gone out, you've gathered the information that you need. The next step is to come back with your team and do a brainstorming session. Okay? How many people have done brainstorming sessions? Okay, we sit together and you throw ideas back and forth. And so what we've done is we've put together a whiteboard for the brainstorming session. And this, by the way, all of these whiteboards, even though it may seem a little tedious, will help you to kind of collect your thoughts, gather your thoughts, kind of track what you've been doing and the process that you're going through to solve the problems. But we're going to come up with some solutions. Okay? There may be multiple ways of looking at this problem, multiple answers. So what you do is you list out the different solutions that you've come up with. You rank each one, pro and con. What's good about this one, what's the con about this one, and then decide as a group which one has the most merit. Okay? Which one is the most likely solution that you're going to go after. And then finally, testing your idea. Okay. How do you validate your solution? Once you've come up with an idea, you have to test it out to make sure that it actually works. So we have a whiteboard that where you document that part of it. First is list the criteria for a successful solution. In the beginning, when you were framing the problem, you were looking at all the problem parameters. You defined what does the solution have to have, what questions does the solution have to answer. Okay? So you list those out and then indicate how your solution addresses that criteria. Okay? Does it answer the question? Describe in detail how you would test that solution. Some solutions are are easier to test than others. Okay? In this particular problem, this wasn't actually a difficult one to test out. So you can actually come up with a test plan for testing out the solution and really validating whether your answer is correct or not. And again, what was the question in this problem?
Can the laser hurt the guy's eyes?
Can the laser hurt the guy's eyes? Okay, good. So this problem-solving cycle really comes from the scientific method and the engineering problem-solving method. Engineers and scientists use this process day in and day out to solve problems and answer questions. Scientists and engineers, good problem solvers, are people who have internalized this process. They've gone through it so many times that it becomes second nature to them. So whenever you solve a problem, whether it's trying to figure out if a laser can fly a pilot or making a pizza, you can use the same process, going through, figuring out what you know, what you don't know, going out and figuring out how to learn that information, the knowledge to do the particular task, and then testing out your solution. So it's a good thing to learn, and in our experience, in doing this for many, many years, it's a little weird at first, okay, but you will get used to it. The more you do it, the better you'll become, the better problem solver you'll become. And that's really what the real world is looking for. So, what we're going to do is break you guys up into 3 teams of 4, and I'm going to give each team a set of whiteboards on paper. You can use the whiteboard on the board, the actual whiteboard, if you'd like, feel free. But get together and start working through the whiteboard, starting with the problem analysis section, listing out everything that you know, everything that you need to learn, and then work through the independent research whiteboard. And then whoever has a laptop, you can go out and do the research that you need to figure out, to answer some of the questions that you've posed. Get together, brainstorm a little bit about what your approach would be to solve this problem, and then document that. And one of the things we're going to do is, partway through this process, you may need more information. Okay, so try to document as much as you possibly can on the whiteboards, right? And at a certain point, I will provide you with a little more information. We have another video that's called the discussion section, which is actually the brainstorming session that the people who solved the problem went through. Okay, and it can provide additional information and hints as to which direction to take. Okay, good. If you have any questions, I'll be floating around. Okay, probing, finding out what you're talking about. Okay.
For the next 45 minutes to 1 hour, the instructor walked among the groups, keeping them on task, answering their questions, and guiding them towards the solution of the problem. In Part 2, we show the discussion, the student solutions, and their reaction to the method of teaching.